Hello friends and my dear students. In the previous 3 episodes you have seen the all trigonometric, inverse trigonometric formulas, then how to solve different kind of questions based on that. So we have done two exercises, exercise 2.1 and 2.2. Now we are going to start today the miscellaneous exercise based on chapter 2. In this there are questions which are mixed questions. Every kind of formula will be used. So you have to decide that what kind of formula is to be applied. Question number 1. It says solve or simplify cos inverse cos 13 pi by 6. Now the question arises, how do we simplify 13 pi by 6? If I divide 13 by 6, I will get 2 pi plus pi by 6. Now cos 2 pi plus pi by 6, using the periodic function, this will become cos inverse cos pi by 6, and the answer is pi by 6. Simultaneously you must check whether this lies in the principal value. Yes, it lies in the principal value of cos inverse, so our answer is correct. I hope you must have understood this. Now moving on to the second question. Simplify tan inverse tan 7 pi by 6. Again, using the previous knowledge of class 11th, if I divide 7 by 6, I will get pi plus pi by 6. Tan pi plus theta comes in the third quadrant, so we get tan inverse tan pi by 6, and our answer is pi by 6. Again, this pi by 6 belongs to the open interval minus pi by 2 to plus pi by 2, and hence our answer is correct. Now let's move on to question number 3. Question number 3 is prove that 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. Now friends, we can start from the left side or we can start from the right side. Let us start from the left hand side. First of all, this 2 sin inverse 3 by 5. I'll convert this sin inverse 3 by 5 in terms of tan inverse. As we have done in the previous exercises, we make a triangle. This is 3 and this is 5. Using the Pythagoras theorem, we get this value as 4. So we get 2 tan inverse 3 by 4. Now, apply the identity of 2 tan inverse x. Applying the identity of 2 tan inverse x and converting into tan inverse, we get tan inverse 2 into 3 by 4 upon 1 minus 9 by 16. So this gives us tan inverse 24 by 7 on the simplification. So we have seen that first of all we converted sin inverse in terms of tan inverse, and then applying the formula of 2 tan inverse, we converted the question as the RHS. Now moving on to question number 4. So you have seen that all these questions are basically related to the formulas. If you remember the formulas correctly and you are able to apply them correctly, the inverse trigonometric functions becomes very, very simple. Now moving on to question number 4. To simplify, sin inverse 8 by 17 plus sin inverse 3 by 5 is equal to tan inverse 77 by 36. There are identities in which we can apply sin inverse x plus sin inverse y, but As per the curriculum prescribed by NCERT and CBSE, we should not use that formula. So first of all, what we are going to do, we will convert this sin inverse 8 by 17 and sin inverse 3 by 5 in terms of tan inverse. For that conversion, if I make this triangle, this is for explanation. If this is 8, this is 17. Using the Pythagoras theorem, we see that it will become 15, and in this, if this is 3, this is 5, this becomes 4. So we convert this as tan inverse 8 by 15, and sin inverse 3 by 5 becomes tan inverse 3 by 4. Dear students, even if you don't show this triangle and you can apply directly conversion, there's no problem. Now apply the formula of tan inverse x plus tan inverse y. This will become tan inverse 8 by 15 plus 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. We have used the identity tan inverse a plus b upon 1 minus a into b. And on simplifying, we get tan inverse 77 by 36. So dear friends and students, first of all we convert in terms of tan inverse both the identities and then apply tan inverse a plus tan inverse b. Now we see question number 5. The question number 5 says to prove that cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. Again students, we should not use cos inverse x plus cos inverse y identity directly. We must convert them in terms of tan inverse. If I make this triangle, this is 4, this is 5. Using Pythagoras theorem, we get it's 3. If we make another triangle, this is 12, this is 13. Using Pythagoras theorem, this is 5. So we convert this as tan inverse 3 by 4, and this will become tan inverse 5 by 12. Again, like the previous question, we apply the formula tan inverse x plus y upon 1 minus x into y. This gives us tan inverse, this is 36 plus 20. 36 plus 20 is 56 upon 48 whole divided by 48 minus 15, which is 33 upon 48. So this gives us tan inverse 56 upon 33. See again students what we have done. Now this is not the end of the question. We need to convert this in terms of cos inverse. We need to convert this also in terms of cos inverse. So converting in terms of cos inverse, this will become cos inverse 33 by 65, again by using Pythagoras theorem. So you have seen how do we solve these kind of questions. So dear friends, today we'll stop here. Try doing all the questions and see you by the next time. In episode 5 we will take up the other questions of the miscellaneous exercise. So keep sharing and subscribing to our channel, Ashish Singhal #mathematics. Thank you.